So, hi. I have two disappointments for you. One is I'm not Mengxiao Ju. That's a picture of my colleague who is the first author on this paper. She couldn't be here, so I'll present. The second one, which is worse, is that there's not going to be anything about language and writing in this talk. So if you want to leave, now's the time. But I will. It is this issue of fitting puzzle pieces together and organizing a conference, and sometimes there's nowhere else to put the talk. So they put us here. So I hope I will entertain you, even though you came for a session on language and writing, and you'll learn something about exponential graph models. Let me tell you a little bit about where this project fits into the bigger picture of what it is that we're trying to do. So there's a number of organizations whose logos are at the bottom of the slide, and with some little bit of funding from the National Science Foundation in the United States. We're interested in modeling social interaction and performance in online and blended courses. And this is not the whole of this project by any stretch of the imagination, and it's a bit of a cartoon in and of itself, but it's the idea that I want to convey to you the most is the goal of a kind of richer model of the learner, in particular as a social learner. And the idea that this is something that is temporal, it's evolving, a unit of time that might be reasonable for a higher education course of study, might be week by week. And in any given week, we can imagine that the learner has internally, and these can be taken literally as sort of latent constructs, if you like that, or you can treat this as kind of more descriptive variables about the learner at any given time. But some of those dimensions of the learner are cognitive in the traditional sense of what they know, what they're able to do, and some of them are more socio-affective in terms of how they feel. And if you are collecting data from an online course, which this paper is about, then the kinds of observations that relate to their cognitive performance might come from quizzes. It might come from the way they use the materials for learning, whether there's a textbook or the videos. And it might come from textual analysis of the traces that they leave in places where they create text, such as discussion forums. So similarly, the socio-affective dimensions can come from those textual traces if you do that kind of analysis. And from just aspects of their connectedness to other students in a discussion forum if they're responding to others and others are responding to them. And so you can come at that from the way they use the discussion forum and if you do some social network analysis. So the idea is that in any given week, and of course there are other features that I haven't put in here, this isn't meant to be exhaustive. In any given week there are sorts of observables that represent evidence about the state of a student, and they change from week to week. And some of the things that interest us are how do those persist, and in particular do the cognitive dimensions have an impact on social dimensions in subsequent weeks, and also the other way, do social connectedness dimensions have an impact on performance. So that's the kind of goal. We're not there, but the other thing I want to say about this in a slide that doesn't say much, is that note everything about this is sort of local in time. Nothing here is aggregated over the whole course, and we're not looking at summative outcomes. We're not talking about trying to predict whether they complete the course or if they drop out of the course. We really want to understand where they are over time. So in the case of MOOCs, if you're thinking about a massive open online course and what social learning behaviors look like, different courses have different affordances for social learning, but the one that is sort of common to pretty much all online courses is some sort of a discussion forum. And what I want to say is that the discussion forum is, of course, two different kinds of resources at the same time. On the one hand, it is a content resource, which is to say a lot of the ways students use discussion forums is to try to find out answers about what's expected of them in the course or how to do the homework assignment in week 3. And they may just go in there and find those answers. That said, it's not the same as going into a textbook to find the answers, because of course if other students didn't create questions and answer them in the first place, there wouldn't be anything in the discussion forum. So it is an interesting content resource because it's dynamic and generated mostly by the students, although teaching assistants and faculty contribute. The other thing about the discussion forum is it's a social resource, and it's clear that some students use it that way. They look for people who share certain feelings with them. Sometimes in large enrollment international MOOCs, they try to find other people from the same part of the world that they are. They do try to form communities, sometimes explicitly in the forums. And so that kind of touches base with some of the sort of big ideas in social learning theories, whether it's social cognition in terms of learning from the things that other students in the class are doing by the way they talk in the forum or the way they solve problems, or actually socially constructed knowledge in a kind of Vygotskian sense, or even a sort of really kind of extreme connectivist view that we really want to distribute learning and artifact creation in this radical way, although that is definitely more a design consideration in MOOC. So if your MOOC isn't a connectivist design, that's not going to likely to happen by itself. So back to the picture, let me now contrast the sort of vision with the reality and strip it down a little bit. So the first thing I told you we're not going to have any of is language, although we intend to, and we have collaborators, some of whom are in the room, and if you heard Scott Crossley's talk earlier today, he's one of them, and Danielle McNamara, but we don't have any natural language processing features in the present analysis. The other thing that we won't do in the present analysis is have a latent structure model. This sort of idea that there is something in the middle of this kind of plate model that represents the dimensions. We're going to take that out and replace it with something explicit, which is the social network formed in the course. So the social network exists in the sense that there is some sort of response network between students in the course, and what we'd like to do is not just look at that as a thing in and of itself, but think of the social network as an emergent phenomenon that is generated by some process that includes other aspects of the students as covariates. And so the framework of exponential random graph models is what's going to allow us to do that. And this is a picture that sort of says that in any given week, the social network, the structure of the social network may be informed by other things about the student that they do outside, such as how well they're doing in their quizzes, or how engaged they are with the learning resources, or how they're using the forum, even if they're not, so whether they're posting or reading. But this is sort of just a snapshot week to week. The next thing we want to do with that is connect weeks to each other and see that the social network in one week is also informed by things the student did in the previous week. And that's the beauty of the framework, the statistical framework we're going to use that allows us to do that. It allows us to create a social network that is informed by variables about the student, not just in the present week, but in the last week, and even kind of connecting backwards to a certain extent. How do future features affect this week's network, which sounds like a ridiculous kind of, I'm messing up my temporality argument, but really what we're looking at here is not a causal model anyway. So if there is a significant relationship between future performance and present social network connectivity, then you could maybe take away from that that being connected helps you down the road. Okay, so you've probably seen social network analyses before. Most of them are descriptive. It was really interesting for me to see that tomorrow there's another talk that also uses exponential random graph models as a generative model for social network analysis. And I'm excited to go to it. But if you've seen descriptive models, you've seen something that looks like this, right? There's sort of a graph where the nodes represent people in the graph, and the edges between the nodes can be directed. There's an arrow, and they may represent someone responding to someone else. So this purple node has a lot of arrows coming out of it, meaning that in this directional convention, this person has asked a lot of questions that have been answered by different people, and you can also have someone who answers a lot of questions asked by different people, and that a measure of that, a descriptive measure of that at any given time is in degree or an out degree, and you can then ask questions like, well, who are these super askers and answerers, and what makes them different, and do they generate good resources when they post things, and so on. So we're not going to do that. And the bridge to the framework that I want to walk you through is sort of through this just basic look at this data. So you can look at this is some data. And you can say, oh, well, what's going on with those 4 points that are kind of off to the left and the upper left? You know, they're low in whatever the x variable is and high in whatever the y variable is, and what is the significance of that? But actually, a statistician would look at this and just say, these are data that are consistent with a random generating process where, you know, there could be some means, which because there's no scale here wouldn't mean anything, but there would be some covariances, which would represent how, you know, how the correlation between, in this case, these 2 variables, right, how diagonal they are, for example. So that first instance was just an instance of a generating process where by any random chance you're going to have some outliers or some people in some, you know, and it would be not necessarily wise to attach too much significance to that. So in the same sense of this kind of just bivariate, multinormal, you know, multivariate normal distribution of points, you can think of the network itself as the product of a generating process. And so all of these are networks. Now there's edges. And you can see that in the, you know, bottom right, there's a node that has 5 connections. But these are all generated by exactly the same random process, right? There's nothing significantly different about that network. By definition, these are just draws from a distribution of networks. And the same thing can be said, right, so in this case, I'm not specifying like means and covariances, but I'm specifying certain variables that apply to networks, like the density of the network or degree distributions of the network. So one thing I can do is I can specify homophily or heterophily of a network. And here are, again, generated networks, but in the ones in the top, there's a preference to form connections with someone who's different from you, right? In this case, the blue nodes are more likely to be connected to the gold-colored nodes, whereas in the lower 3, there's a tendency to form connections with people who are like you in some way. And so similarly, reciprocity, if you have directed networks, and transitivity are statistics that you can specify in a generating process. So the advantage of doing that, of setting up that generating process, is that you can now test hypotheses about whether reciprocity is an important factor in this network or homophily is an important factor in this network. And that's what this framework of exponential random graph models allows you to do. Kind of like regression analysis allows you to say whether certain predictors are significant in the outcome of interest. And this has been around for some time. So some of those references there are actually applications to distance learning, but I think I should probably move on to our specific application. But if you've heard of latent space models and stochastic block models, they're very similar. Okay? So back to what it is that we wanted to know is we were asking about individual performance and their engagement with the learning resources and how that relates to their connectedness in a network. And I put a big star here because we're very narrowly defining social connectedness here in terms of a reply structure of a network. So if somebody responds to me, they will be connected to me, and as I will say more, it's a very, very coarse view of social connectedness, but it's a placeholder, right? And the second question is there sort of some longitudinal significance to this? So the data set comes from a MOOC. It comes from the MOOC Big Data in Education, which has been offered a couple of times, but from the first instance, it's Ryan Baker's course. that was originally a teacher's college course, and it was offered on Coursera. It was 8 weeks long. There were quizzes. Like many MOOCs, a lot of people enrolled. A smaller number of them were actively participating, and a smaller number still were actively participating in the forums. And so the selection effect for our sample is that we're down to about 770 who posted something, and therefore we can see among those 770 students what the relationship is between the network structure and these other covariates that we're going to look at. So the basic methodology is you create a network for every week. That's pretty easy to do. And you also collect these attributes every week. You collect their assignment scores. We actually went a bit farther and did a kind of complex analysis that used took advantage of the fact that they had multiple attempts on the quizzes, and so kind of gave them a performance score that took into consideration the multiple attempts, even though the actual grade didn't do that. And their engagement variables, by which I really just mean how much do they watch, and how much instructional videos do they view or download, and do they post. When we construct the social network, social discussion forums, depending on the platform you're working on, have different affordances for like whether there's a difference between a comment and a reply. We ignore those distinctions and treat them the same. So if you comment or reply to a thread, then you are connected to the original poster of the thread. So this is a sort of picture of what happens. You're only connected to the original poster. You're not, in this case, connected to everyone who came before you. And that's a choice. That's a methodological choice. So then you get this picture that looks like this. I said you've probably seen these. The point is that one thing that's obvious is the network gets it gets smaller as the course goes on because of attrition. So you can see sort of just some very gross network statistics over time. The size of the network gets smaller, the density of it gets higher. I'm not going to concentrate that much on this. I mentioned that the node variables that we want to add fall into the categories of performance. Not only your current scores this week and how they sort of predict whether you're likely to be connected in this network or not, but also past and future scores. And we looked at score differences to see whether you're more likely to be connected to people who are similar in their performance to you or different in their performance from you. So here's how we then build the models. So we build the models a little bit like the way you build regression models, stepwise, starting with something very simple and then adding more complexity. So the simple version is just accounting for network features. This is network structure. Density is the simplest network structure you have, right? You want to say there's a certain probability of a connection between any two people, and it isn't necessarily 50% if it's a sparse network. Okay? But another thing that you would want to do is you want to account for hubs. There is, in most social networks, there are hubs, right? There are people who tend to be connected to a lot of people. So we might call that preferential attachment. Somebody who's already connected is more likely to have more connections, right? We all know those people in our lives. So a way of accounting for hubs is technically through something, a statistic, called alternating k-stars. This is a mathematical formula for sort of a network feature. So that's our base model. This was our base model. That's sort of just kind of, we want to control for those when we begin to introduce the variables that we're actually interested in. So the current week attributes are the next step up, where we take into consideration the score, the performance of the student in this week. We take into consideration the difference between them and each of the other nodes in the network. We take into consideration how many posts they've been reading and how many lectures they've viewed. So these are the current week attributes. If you look at the paper and you see the sort of the numbers, this is what model 2 is. So each model builds on the next, and so like a regression, you're already controlling for these variables when you add the next set of variables, which is now the previous week attributes. Their score last week, the posts they read last week, the posts they made last week, which we can include now because they don't connect them in the present network, and the lectures they viewed, and then finally we'll add 2 variables from the future regarding the scores and the lectures. So I see that I'm running low on time, but it's actually fine. What I really wanted to convey to you was the spirit of the model. The mathematical equation, if you really want to see one, looks something like this, but it's not very explanatory. Everything in that exponent is some kind of linear combination of weights on these network features, and the network is now seen as a realization. And when you do this analysis, you estimate the network, usually in a kind of Markov chain Monte Carlo algorithm. You can do it in R. There's an R package called ergom, which you can then look at the sort of convergence of all the Markov chains and so on, and look at the posterior means and see if they look good. And then this is what you get. So all I'll say is interesting findings in week 2. So week 2 is the first week in which we can look backwards and forwards, right? So interesting findings in week 2 is that we don't have preferential attachment. That typical thing that you often had in social networks, we don't have this tendency to form hubs. So of course there will be a couple of hubs in this course because of the teaching assistants and the professors, but they aren't enough to make the network sort of think that it comes from a place where hubs are important. When we add, what happened here? Yeah, when we add the things that we wanted to look at, we see that scores are significant effects. So performance is positively correlated, meaning the higher performing you are in the present week, the more likely you are to be connected in the present week. And actually that turns out to persist across the future, across the past, and the future. So yeah, I'll let you look at these tables in the paper because it's really hard to look at them here anyway. And just say, here's the sort of downside. The downside is there were kind of some really interesting findings substantively from week 2. We didn't take them too seriously in any case because the network is so coarse, right? It's really just a who replied to the original poster, right? We didn't look at what they said or how they said it or anything like that. So we just kind of wanted a proof of concept. But not only that, it wasn't stable from week to week. Okay, so whatever appeared to be significant in week 2 wasn't necessarily significant for the week 3 network looking back and forth, or the week 4 network back and forth. So there's sort of, reason to take all of these results with a grain of salt. But the things you can do from there is you can do a meta-analysis. Okay, so that's kind of what it sounds like. Instead of doing every network by itself, you can again try to see that the network coefficients that you learn are sort of descended from some higher level distribution. If you're into sort of hierarchical models, you can think of it as a hierarchical model. You can change the structure of the network to take into consideration that when someone is responding to me, they're not really responding to me, they're responding to the thread that I created. So if you have a bipartite network, you can introduce different kinds of nodes. Nodes for people and nodes for threads, where someone can sort of be the creator of a thread and other people can respond to the thread. And that might be a sort of more authentic characterization of what's actually happening. We don't draw causal conclusions. I just wanted to put that in bold. And then say, thank you. We are in the process of collecting some more data, and in particular, we're looking for data from courses that expressly claim to have a kind of social constructivist design. So they claim to be looking to cultivate social learning, and if so, we think there'll be better data sets than the particular one that we sort of tested this out on, which made no such claims. All right, so thank you very much.
Thank you. Okay, so we have time for some questions. I'd like to ask one question, and if you think it's an unfair question, you don't have to ask it, because I think it's a really hard question. But what do you think would be a better definition of a link? Because I find I'm very frustrated when I read these social network analysis papers, because if you read the forums, and I think lots of people have acknowledged this, replying in a thread doesn't necessarily mean anything very substantial on a social level.
Yeah. Right. Well, so that's where I think that natural language, piece is key. So that's not much of an answer, but it's just to say that we need help from sort of other computational methods to say there should be a link here, and also, you know, the weight of the link doesn't have to be just on or off, right? So this is a response. Carolyn's clearly responding to me, and she's responding in a friendly, helpful way. So that would be certainly much more informative, and that's sort of where we want to go.
Okay, questions?
Thanks for your presentation. I was just wondering, would there be anything to be learned by reconstructing the data with the nodes that were in the final week so that they remain static for the whole of the data set, and whether would you expect to see differing patterns with the same nodes through the whole thing?
So I'm not sure I understand.
Change.
So the nodes in week 8 are the students who are posting in the discussion forum in week 8. And,
yeah.
And so
I'm thinking of a kind of a compensation for the attrition effect.
Oh,
to
I see what you're saying.
Can we learn about those learners that are still present posting at the end?
Right, right. So there's sort of two aspects to this answer. One is that, again, we have to, in the framework of exponential random graph models, we have to avoid personalizing the nodes because they're just random, right? You know, like the whole network itself is random, but it happens to be a network of a certain size. And so we don't want to change the fact that the size of the network is smaller at the end of the course than it is at the beginning of the course, because that's true. So we're going to model it with a generating process that accounts for that size. But we could try to account specifically for attrition as a connector from week to week, which we didn't do. We just took each one as sort of like an empirical fact of that's how big the network is.
I'm wondering about the choice of exponential random graphs.
Mm-hmm.
I mean, there are many different ways of generating random graphs. Did you think that one was most appropriate in the context of MOOCs, and why so?
This is a better question for Mengxiao, who is more familiar with the different set of methods. But if I can channel her for a moment, I would say that, you know, exponential random graph models, as you can kind of have all the degrees of freedom you need to do most things. So there's certainly in stochastic block models, or if that's what you're thinking of, you know, like Tracy Sweet and Brian Junker's works, they go at it, you know, from a different approach. They have sort of like logistic models of the nodes and stuff like that. But it seems to me that the degrees of freedom are there, so you're not really going to, you're just going to, you know, get the same, you should be able to find the same significant variables if they're there.
Did you try different ones?
We didn't, no.
More questions? Okay, I'd like to call the next speaker up to set up her computer. And so while she's doing that, if somebody thinks of a question, just throw your hand up. Actually, Yoav, you didn't spend a lot of time talking about what you guys found, but since we have a couple of minutes while we're waiting for the next slides to be set up, can you just say a few words?
I mean, I'd rather not, because I do want to be sort of the conservative on the findings, because I think I don't trust them that much. Like what I appreciate that it would be nice to say that the fact that there was a positive correlation between future scores and connectedness in the network is kind of an encouraging thing that you might then say, oh, well, we should encourage our students to be more active in the network. We all know that that's sort of a, you know, a cagey proposition, even if you feel that you've operationalized the variables as well as possible, and I don't feel that we have. So no, I guess I'm just too hedgy about the substantive findings.
Okay, I appreciate your concern.
Yeah, somebody has to go the opposite extreme and back away from all of their claims, right? Yeah, okay.
Thank you very much.